Welcome to the GeoDict Session 4 here at the IBSim 2020 conference. I will show you how to enhance productivity with Python in GeoDict 2021. So if you don't already have, start GeoDict 2021 to follow the steps done in GeoDict. I'm Janine Hilden. I studied applied mathematics in Trier, Germany, and I'm an application engineer at Math to Market since 2018. I do some project work, documentation, and trainings like this. The goal is that after attending this workshop, that you will be able to record and playback macros with GeoDict in order to automate common and repetitive tasks. Also, you will learn how to add variables to macros to optimize or analyze materials running parameter studies. Finally, you will see how to access any GeoDict result from a Python macro. In detail, we will start in part 1 with macro recording and parameter studies. There I will introduce you to GeoDict commands. I tell you what they are and how do they work. And then we will record and playback GeoDict commands in form of macros, and we will take a look at the structure of a GeoPython macro. We will introduce variables in the macro, and we will use macro for a parameter study. Afterwards, we will have the first break for questions and refreshing. In the second part, Python language basics as text output, variables, and string operations will be explained. Furthermore, we will add a second variable and do another parameter study. After the second break, we will go on with part 3, where we will record a simulation and access the results from a macro. Also, we will save images from the simulation results, and finally, we will give an outlook on some advanced topics. So let's get started. In GeoDict, almost every action is a command. For example, if you load a structure file or save a structure file or results, every simulation, and if you render images or movies, everything is a command and can be saved to macros. Each command has a name and a set of parameters, for example, a result file name, some binary condition, solid volume percentage, and so on. Therefore, the actions in the user interface execute corresponding commands. These commands can be recorded in a macro, and this macro will then consist of a list of commands with their parameters. And if the macro is played back, then the same commands are run again. Additionally, macros can have variables, which can also be set in the user interface. And of course, we want to see these macros and commands and how they work and how to record macros. So therefore, as a first example, we create a macro for structure generation. And for this workshop, we will generate a fibrous structure. And I will go on performing the steps live in GeoDict. So first, select a project folder which fits to this workshop. So we've already prepared an empty folder inside the workshop materials folder. So would recommend to use this. Therefore, click on File, choose Project folder, select Project folder, and then navigate to the workshop materials folder. I've saved it to the desktop, for example, and then to the project folder. And then click Select Folder. Now GeoDict will save all following results in this folder. So there are two possibilities to save commands in a macro. One way would be to start macro recording, then execute the commands in GeoDict that you want to record and end macro recording afterwards with the start and end macro recording buttons. And the second possibility would be to record the commands afterwards. Both ways have their advantages. But we choose the second possibility in this workshop, which has the advantage that you don't need to know beforehand what you want to record. You can simply select the right commands afterwards in the session macro dialog. So now, as we want to create a fiber structure, we have to choose the FiberGeo module. Therefore, here click on Model, and then FiberGeo. And then FiberGeo should be displayed in the module section in the bottom left of GeoDict. So to be sure that we have all the same settings, we click on Edit and load the built-in default settings, which is the third icon here on the bottom left. So now we should have all the same settings. For example, here the result file name, FiberGeo GDR, the domain size 200 voxels in X direction and in Y and in Z direction, voxel length 1 micrometer, and the stopping criterion, the object solid volume percentage of 10, which would be 1 minus porosity in percent. So the generated structure will have 10% solid material and 90% pore, so in this case air. Click OK and click on Generate. So this is the result viewer. For the moment we won't need it, so you can simply click Close. And here we see the generated fiber structure in 2D. So let's visualize it in 3D. Therefore, click on View, 3D Rendering. Or you can also use the buttons here in the toolbar for 2D and 3D. You can turn around the structure by clicking on it and holding the left mouse button. To record the generation of the fiber structure, now we click on Macro, Session Macro. So for the current session, GeoDict automatically records all commands from the user interface. They are listed in the upper panel of the Session Macro dialog. In the beginning, we find some commands of starting GeoDict. For example, the expert settings, changing a project folder, and the preferences. In the end, we can find the commands we executed together. The FiberGeo create command generated the fiber structure. Afterwards, the corresponding result file was loaded and closed again. So we will need this command. Here, all parameters of generating the fiber structure were saved. To save this command, we highlight it here by clicking on it, and then we click on Add Selected Commands to File. Then the command will appear here in the bottom panel, and everything which is here in this panel will be saved to the macro when clicking Save. So we click on Save, and now we have to choose a name. For example, we can call it Workshop 1. And as we see here, it is saved to the project folder by default. I've already built the fiber structure, which is saved inside the result folder. To see any effect when playing back the macro, we will discard the structure. Therefore, click on File, Discard Structure and Fields. So now everything is empty again in the visualization area. And now we want to play back the macro. Therefore, click on Macro, Execute Macro Script. Now the macro execution control opens. Here on the left we have the 3 built-in default folders. In the first folder you can find many helpful example macros and tutorial macros, which can help getting started with GeoPython. And the second folder, the session macro folder, for each GeoDict session a macro is saved. This macro contains all commands executed in the session. For the current session, they were displayed in the session macro dialog that we've seen before. And the third one is the current project folder. We can unfold it, and here we find the macro that we saved before. So if we highlight it, Here on the right, we can see all the commands that are contained in the macro and this helpful preview panel. And in this case, it is of course only the fiber structure generation. So to play back the macro, we simply click Run. So as we already generated the structure with the same name and the same settings, GeoDict asks us if we want to overwrite it or backup. We can simply click Overwrite because it's the same as before. And now we see the same structure was generated again. So now we want to take a look at the macro. Therefore, go back to the macro execution control, highlight the workshop 1, and click on Edit. So now we see the macro file starts with a prologue, which has 3 parts. First, we see here the header. It gives some information about the used release, which of course is now 2021, the used revision and the build date of the revision and the creation date of the macro, the time that it was created, who created it, on which platform it was created. Afterwards, we have a description. By default, it gives only some information that is also contained in the header. And this description is displayed in the macro execution control here in the bottom right panel. We can change it to everything what we want. We can change it containing information about what the macro does. So if you recorded a macro and then you can give it to your colleagues without that they need to look to the source code, because here you have a description what it does. So for example, you can simply add, so this macro generates a fiber structure. And if you then click on Save and go back to the macro execution control and click Refresh, then you see here the description appeared. So after the description comes the variables section. By default, it's always commented out example of the solid volume percentage, which is part of many structure generators in GeoDict. This variables block consists of the name, which is used inside the macro, the label, which will be seen in the user interface, a type, so it could be double or which would be a floating point, or it could be an integer or also a string. So the unit in this case would be percent because it's the solid volume percentage. A tooltip that can be seen if you hover over the label in the user interface. A built-in default value, which will be seen in the user interface, and some check so that the solid volume percentage is at least 0 and maximum 100%. And then commented out explanations of the variable syntax follows and some examples of variable usage in GeoDict command lists and frequently used Python syntax. Comments are always introduced by a hash in Python. So everything which comes after this hash is ignored while executing the macro. The macro is always executed from top to bottom. So here comes the block with the recorded commands. In this case, only the command of the creation of the fiber structure. Everything before is always a part of every macro recorded in GeoDict, even in an empty macro. But now the command section follows. So here we have the creation command for FiberGeo. The parameters are always saved in a Python dictionary, which is assigned to a variable. In this case, the create args1. A dictionary always consists of key value pairs. So here on the left we have the keys, and on the right the values. So we can, for example, see here the number of voxels in X, Y, and Z direction we've seen before in the FiberGeo user interface. And here the solid volume percentage we've seen before. And the result file name. So in Notepad++, you can collapse the sections by clicking on the minus beside. You can also collapse only the domain or the whole command dictionary. And here you can see in the first line after the dictionary follows the execution command, the gd1 command. And here you see the variable name is used. So it knows which dictionary belongs to the execution. And which GeoDict command is used, and which release is used. So here you could also only be displayed 2021 because this is accesses the header dictionary, which we see here. It takes the release date, so it means 2021. So we now have a macro that always generates the same structure. This is not very useful. What if we want to vary some aspect of the geometry generation and generate several variants automatically? We need to vary some parameter of the structure. Therefore, we can use a parametric macro and vary the parameters from the user interface. So variables in the variables block here in the GeoPython macro can be assigned a value by the user directly from the user interface. This allows you to write a parametric macro and provide it to colleagues who can use it without ever touching the Python source code. We save a copy of the Python file as workshop2, so we don't lose the original. So therefore we click on File, Save As. Change it to workshop2. Make sure that it's saved to your project folder again. And if you don't have Notepad++, make sure that the right type is also chosen. Notepad++, the file is automatically that you use here in the ending. But in other editors, it could happen that this would result in workshop2.py.txt or something like that. So then make sure that you choose the right type from this pull-down menu. Then click on Save. And now we change the number of variables to 1. And then we uncomment all of the green lines, removing the hashes. So now we have the solid volume percentage as a parameter which can be set from the user interface, but it has no impact on the macro yet. So this floating point variable, which the name GDSVP has to be set here in the dictionary of PyBarTeoCreate, therefore unfold it, and then look for the solid volume percentage key, which would be in line 107 for me. And then we change the value 10 to the variable name, which is GD SVP. And then we click on Save. And we go back to the macro execution control, clicking macro execute macro script. And if you didn't close it like I did, then the workshop 2 is not available here. But if as soon as you click refresh, it appears. So you can see while workshop 1 is highlighted, the parameters button is grayed out because it has no parameters. You click workshop 2, then you see the parameters button becomes available. So click on it and change the solid volume percentage, for example, to 25. Click OK and click on Run. So now it is another structure, so we could change the name to PyBarTeo25. This can also be automated. We will see it in the second part. Click on Rename. And now we see that a much denser structure was generated. You can also validate the solid volume percentage by looking here to the Statistics tab and unfold this pull-down menu. And here we see that we have 27% pore and 25% solid. So see here the structure only consists of glass, so we can here see the whole solid volume percentage. So and the second part, a flow simulation step will be added. And as the simulations themselves are not so important in this workshop, we can generate smaller structures to decrease simulation time. So we go to the domain of the Create args1 dictionary and look for the domain parameters X and Y and Z and change the number of voxels to 100 for all 3 directions. This would of course not be a representative cutout, but in this workshop we only want to see how it is automated, and so for decreasing simulation times in the workshop, this would be reasonable. So click on Save. And the next step would be a parameter study. So now we can see the benefits of adding a parameter to the macro earlier, because we can vary its value automatically. If we go to the macro execution control again, we can click vary here instead of fixed. And if we then click on parameters, we can enter value lists, not only one value, but as many as we want to. So for example, we could enter 10, 40, 70. These values have to be separated by comma, so 10, 40, 70. And then the macro will be executed 3 times, once for each solid volume percentage value. For multiple variables, you can have the given values vary in parallel or even run all combinations cross product. We will let's see also in the second part. So for now, we click OK, and then click on Run. And now, for now, we have to change the result file name manually, but we will automate this in the second part, you will see. So second one would be 40. Can rename, and the third one would be 70. and click on rename again. So now if we go back to GeoDict, we see here the last one with the 70 solid volume percentage, which is very, very dense. You can validate it again in the statistic tabs. Here you can also see the 75% solid volume percentage for glass. And if you want to see the results of the whole parameter study, we can look to our project folder. If we click on File, choose Project Folder, and Open Project Folder, and then the project folder is opened, and we can see here all the results that we've done now in this first part. And we can see, for example, the first one we only used for recording the macro, and then here the 25, our first edited variable, and then now our parameter study, the 10, 40, and 70. So as always in GeoDict, the results have a result file where all the parameters are saved and all results are saved, and an additional folder where the structure, for example, is saved, or some result fields. So here we can also see a picture of all three parameters. Here all fibers are all fibers got the same color, and we see here how the structure is denser and denser with more solid volume percentage. So this is the end of part 1. We've seen how to record macros and insert variables to them for parameter studies. Are there any questions so far? Now we will have 10 minutes break for refreshing and for questions.